Hey guys, Mr. Middleton here. Today we're looking at volume of prisms and cylinders. At the end of this video, you should be able to find the volume of a prism and cylinder. Okay, surface area. We just got done talking about surface area. We've talked about surface area of all these of prisms, cylinders, pyramids, cones, and spheres. And now we're going to get into our second part of the unit where we focus on volume. Okay. You guys know that surface area deals with the amount of visible space in an object, where volume deals with the amount of occupied space that object takes up. Okay, it is given in cubic units. To find the volume of a prism, you simply need to find the area of the base and multiply it by the height of the prism. Okay, not height of the base, height of the prism. Okay, and therefore, the formula for the volume of a prism is volume equals B times H, where B stands for area of the base, H stands for height of the prism. Okay, so let's look at a couple examples here. Here they ask us to find the volume of each prism. In this first prism, we are given a triangular prism. That means that the base is a right triangle. Well, it doesn't mean it's a right triangle, but in this case, the base is a right triangle. And so we need to find the area of that triangle. And we can do that using our formula of base equals, in this case, 1/2 base times height. Okay, so 1/2, 8 times 7. And that means that the area of our base is 28. Okay, we can find our volume by doing B times H. So the area of our base is 28. The height of our prism, remember height is the distance between the bases. Okay, so it's 13. And so 28 times 13 gives us 364, okay, units cubed, okay? We're talking about the occupied space. It's a cubic unit in 3 dimensions. Okay, number 2, we're looking at a prism whose base is a trapezoid. Okay, and so that's a little bit different for us, but we know how to find the area of a trapezoid, right? Remember that the area of the trapezoid was 1/2 the height of the trapezoid times the sum of base 1 plus base 2. Okay, so with this information that they gave us, we can find that 1/2 the height of our trapezoid is 4. Write that. Yeah, that's fine. Okay. Base 1 is 14. Base 2 is 8, or vice versa. Doesn't really matter. Okay. So we have 1/2 4 times 22, which gives us 44. Okay. So we found that the area of our base in this case is 44. The height of our prism is 10. And so the volume of this prism is going to be the area of the base times the height of the prism, which gives us 440 centimeters cubed. All right. Here they're asking us to find the volume of this hexagonal prism. Okay, so they tell us that this base is a regular hexagon. And so we're going to have to find this area the same way that we did. Remember that because it's a regular hexagon, our formula for area of a hexagon was 1/2 the apothem times the perimeter. Okay, so looking at these values, first we have, we're going to be dealing with that special right triangle. We've looked at that. So I'm going to just get straight to it, right? Where we have this 30-degree angle, right angle, 60. Okay, they told us that the entire base was 6. So when we're looking at this triangle here, this leg that we know will be half of that, 3. Okay, this is a 30-degree angle. So across from 30 is x, across from 60 is x radical 3. The hypotenuse is 2x, just to finish out those ratios. But the side that we care about is here, the apothem, which will be x radical 3. Since x is 3, x radical 3 will be 3 radical 3. So we have 1/2 our apothem, which is 3 radical 3, times our perimeter, which in this case is going to be 36. And so 1/2 times 36 is 18. 18 times 3 radical 3 gives us 54 radical 3. So the area of the base in this case is 54 radical 3. The height of our prism is 15. And so our volume is going to be 54 radical 3 times 15, which gives us 810 radical 3. Did they give us units? Nope, so units cubed. All right, number 4. They're asking us to find the volume of what looks to be a house, basically. And so what we can do, we have this prism, still a prism, right? And notice that our base is a little bit different. It's kind of like a composite figure in itself, right? Our base is a rectangle with a triangle stacked on it. Okay, and so we can still find the area of this figure and multiply it by the height of the prism, right? Remember, our height's going to be this way because it separates the 2 congruent parallel faces. Okay, so as we look at this, our base is a rectangle and a triangle. Our rectangle we can find 6 times 8, 48. Our triangles, we look at it, they tell us that this height is 4, right? And this base we already know is 8, so 1/2 base times height for our triangle. I guess I can write that as 48. We got that 6 times 8. Okay, and so that gives us 16. So we have 48 plus 16. Our area of our base is 64 centimeters squared. Our height, remember, is what separates the 2 parallel faces. So that gives us 320 centimeters cubed. Okay, so there we go. We've done prisms, and you know that those bases change. We've dealt with some changing bases. Now let's move on to cylinders. Okay, in a cylinder, everything is just the same as a prism, except the base is not a polygon, but instead it's a circle. How do we find the area of a circle? It's pi r squared. Okay, so really, if you wanted to think about it in the most general terms, it's exactly the same. Our volume is going to be the area of the base times height. But specifically for cylinders, because the base is always a circle, we're able to say, hey, instead of just using base like b, like it changes, since it doesn't, let's just say pi r squared times height. Okay. So first question, to the nearest 10th, they're asking us to find the area or the volume of this cylinder. We should be able to find it. Area of the base, our radius is 2, so pi r squared, pi times 2 squared, 4 pi is our base. Our height is 15, so 4 pi times 15, and that gives us 60 pi. Okay, so our volume is 60 pi. Now, the question asks us to go to the nearest 10th, and so we're able to do that in our calculator. Get about 188.5 meters cubed. Number 2. Okay, same kind of thing. You'll notice that this is leaning a little bit. Okay, I want you to realize or know that when we talk about a height, we're talking about the perpendicular distance from the between the bases. Okay, and so still we're talking about this perpendicular height here, and so whether it's leaning or not, this perpendicular height is the height that we'll use. Okay, and so since we have the radius of our figure, 5, we can just plug it into our formula. Pi times 5 squared times our height, which is given to us as 15. Okay, 5 squared is 25, pi times 15, and that will give us 375 pi centimeters cubed. Okay, and that is volume of cylinders and prisms. All right, see you.